There's some issue with my system, it seems. I need to get it fixed. Okay, guys, thanks for waiting. I'll fix it. I'll get it fixed. Some issue with my system. Okay, so we understood how why we consider this or this phase of the part. Okay, uh, and how we consider the plane, how we created the plane, and how we are going to remove this material. Okay, so now after creating this, with the help of this plane, we created this sketch. Okay, so this is the plane we selected, and the orientation is vertical and horizontal. So this is the orientation we wanted. Okay, so now we created this sketch. Okay, so again here you can see we have a reference dimension here. Okay, here is the reference dimension. We just wanted to kept it for our reference. Okay, we kept it this, and all other dimensions, these are from drawing. Okay, so this much material we have to remove. That was our intention. So only this much was in solid, and the remaining was, all the lines were construction. Okay, you can see all these lines were construction, and only this much was solid. Okay, so why are we constructing these lines also? This will give you a very clear visualization or input. Even if you, in future, if you want to check this or someone else is checking, how it happens in the companies actually, once one engineer completes the model, then your senior is going to check your model. Okay, so for that you need to give him all the inputs. Okay, you maybe, if you are, for example, you are working in shifts, you work in the first shift. Okay, if you're working in some Japanese project, then Japanese morning starts around 4 o'clock Indian time. Okay, so they come to office around 4 o'clock because of the time difference. Okay, their morning starts around 3:30, 4 o'clock. They come to office and they start working on that. So that's the reason you have to come and work in the first shift. That means maybe you have to come by 6 o'clock. So you come by 6 o'clock and start your work, and you finish it, your shift completes by 2 o'clock in the afternoon. Then you have to hand over all your work to the next shift guy, and you have to make him understand what you did, what you designed, right? So whatever work you did right from morning, that should be clear to the other person. And even if someone uh, checks it, even after a few months, it should be clear to them. So that's the reason we provide all the input, even it should be clear to us. If you can simply create this block and leave it. Okay, so that's a very simple work. You can just create this and come out, and simply you just remove the material. You just come out and say remove. You're done with this. Okay, how you did it? Again, how to define in work object. Okay, first step we are going. First step, if you want to go to this pad, define in work object. Okay, this is the first pad. And then the second operation was removing of material, that is pocket one. Okay, so we removed material here. So how you removed? So how you created this sketch? So you need to get into this and see, oh, this was the total dimension, and he wanted to remove up to here only. So that's the reason he constructed all the dimensions are correct. How you considered it? Okay, what is the reference point? So this is the edge. So from here, how much you consider? So everything is clear here. Okay, So that's the reason when you work on models, it should be very clear. So this is what is expected even in the interviews. Okay, when you are working, but don't take much time. Okay, you need to do it as I mentioned. Maybe hardly you'll get 1 hour of time, and they'll ask you to finish the model and then finish the drawing. So half an hour for the model, half an hour for the drawing. Okay, so if you start working on all these constructions, construction lines, and other dimensions in minute level, then you will not get time. So in interview, you can skip some of the things so that you can finish it in faster, or you can, only thing is you should show them what exactly is the method you are following. Like as I said, you are aware of the manufacturing method of this process, of this part. If they give you some part, then you, maybe in 1 hour you may not be able to complete that part. Okay, maybe you have completed only 80% of the part, but what they are going to check, they will say, okay, 1 hour is over, just stop modeling it and just come out of the hall. So you come out and sit outside, and they will check how this guy proceeded, how this guy understands the part, okay, manufacturing of the part. So that reveals your knowledge. Okay, so if you randomly, if you design it or randomly you work on the part, then they will come to know that this guy is only Catia guy, he doesn't know anything about the subject. Okay, he knows some options in the Catia, and he knows how to create the pad, how to remove the material using the pocket, and that's all he knows. Okay, that is what you are going to create the impression. When you follow this method, okay, the manufacturing methods, then even the person who is checking your model will come to know that yes, this guy, because this is a sheet metal part, so he followed this method. Because this is a machining part, so that's the reason he followed the second method, so the suitable process. So he removed the material. Okay, so this is how you have to develop your knowledge, just not just learning Catia. Okay, you need to parallelly work on the manufacturing methods and the materials and how it is manufactured. Okay, all these things are very important, so you need to work on that. Okay, okay guys, so we are here. So we remove this, and next step is another removal of material. So these are the holes we remove again. So for removing this surface, this hole on this surface, material on this surface, so again we are going to select this face, that is Z and Y. Got it? And then we selected this face, this plane, and then we remove this material. What was the sketch? Just simply a circle. Okay, and again here we took this construction line. Okay, and just to show that this is the part of it, completely part. Okay, now you understand why are we are considering the construction lines, and why we are considering the solid lines. Okay, okay, so this we finished here, and then next process is removing material here on the bottom side. Okay, based on the dimensions again. So to remove material, again we have to ZX plane. We have to select the ZX plane, and then we have to remove it. Okay, so one line is not constrained here. Okay, okay, maybe left it. How to constrain? Maybe this. This part is not constrained. Okay. Okay, so you understood, right? We'll constrain it. Okay, guys. Now, what is this? this option, normal view. Okay, when you are moving it, when you just rotate it, or and you want a normal view, then please click on this. Okay. Okay, then we remove this material also, this material also removed, and then coming to this one, top material, top hole we did it. Okay, how we did it, we selected which face. So to remove the material on this face, so what is the axis, what is the plane? YX. Okay, this is kind of XY plane. So XY plane, we again created a plane which is parallel to this plane, and at a distance of 70 mm. Okay, that you can see all the planes created will be saved in the geometrical set. Okay, if you click on this, you can see 70 mm is the offset, and what is the reference one? Absolute axis system. So this is the absolute axis system, and from here 70 mm you offsetted it. Okay, and then you use this plane to create this sketch. So this sketch. Okay, and with the help of this sketch, this material, with the help of this sketch, we remove this material. After removing it, next step is removing the complete material on the same face. So you can use the same plane and create this sketch. Okay, so this is the projection, circular projection. You can see the top side of this part. Okay, this projection is of 80 mm diameter, and inside diameter is 60 mm. Okay, this is 80 mm, and again we are going to remove material inside. That is the next step, 60 mm. So this complete material should be removed. So this complete material, so how to remove that? Simply say, create the circle and say reverse side. Okay, when you say reverse side, the material other than this circle will be removed. Okay, guys, don't get confused here. Okay, if you want to remove this material, you can use second method also. What is the second method? What is the one more method if you want to remove this material? Okay, so let us see. At this stage, define in work object. Okay, I'm going to previous step. I'm defining it previous step. So before removing the material, so this was the state. Okay, so there was a material here. So I want to remove this material, and I want to have a projection. Okay, I need to remove this material, and I want to have a circular projection. So how to do that? We simply created out a surface. So if it is out of your view, then you have to say fit all in. Okay, fit all in, it will come and sit here. Okay, if it is somewhere here, then you can use this, say fit all in, and then you need to just maximize the view. And now see, so I have considered just a circle. This is a pad. Okay, if you see the drawing, if you refer the drawing, this is the circle with a thickness of a pad. We can say a pad of thickness of 20 mm. Okay, this kind of wall constructed a circular wall of height 20 mm. Okay, so now we have already material here. So 20 mm material if you remove, then we can have this circular wall kind of thing, wall kind of feature. So how to achieve that? So we simply constructed a circular here, okay, circle here, and then we, once you come out, just click on this and you will come to know. See, this is simply a pocket definition. Pocket, everywhere pocket is used, okay, everywhere pocket is used to remove the material. But here, along with the pocket, which one we used? Another option, reverse side is used, okay. What is the difference between that? Reverse side and reverse direction. If you remove reverse side, then this material will be removed, okay. But we want this material and we want to remove the whole material which is available on the other side, like beside this pad, okay. So say this reverse side, and reverse side material will be removed. Say okay, and say define in work object. So see this, all the material which is adjacent to this is removed, and what we wanted, a circular feature. So we achieved this, okay. Please remember this option. In pocket itself, simply we can use this option with simple circle and remove the other side material. Or else what you have to do, you have to construct a sketch like this and remove this material and remove this material, which is again going to be a difficult task. So this is a very simple task, okay, remember that. Done. And then what is the final option, final thing? So we wanted to remove this material. Why we did two pockets here? Because in one pocket itself we can achieve this, okay. But there is a difference in the height of the, this height and this size. There is a difference. You can see this height is 20 mm and the height inside that is 15 mm, okay. That's the reason we used different pockets here to have clarity, clear step by step process, okay. Or else we also can use single multi pocket definition also we can use, okay. We also have one option where we can use different circles with different heights, different depth of removal of material, okay. That also we will see in near future. I'll let you know in other models. I'll explain you, okay. Okay, so if you look at the tree, so this is the complete model, okay. If you look at now, say defining work object, when you say complete part body defining work object, then it will show you the complete model, okay. Now all the planes are in the geometry, okay. The first sketch will be saved here, okay, and remaining all will be with the options, okay, with the other options which you use here, okay. Pocket, the sketch related to pocket will be inside that, okay. And this is the axis system. This is known as history tree, okay. This is the history tree of the this part. So when you look at this, you will come to know all this history, okay. It should be very clean, and also you need to, you can rename it, okay. Like as I showed you, every feature can be renamed. So here you can rename instead of pad. If you want to rename something else, you can rename it, okay. And instead of pocket, you can rename it. This is like How you can rename? Like complete block, you can say. Okay, this is the or base block, you can say. This is the base block. Okay, and then say this is okay. You can rename it like this. Okay, this is kind of what slot your slot kind of, you can say slot. Okay, and you also this you can say side holes or whatever the name given in that drawing. Okay, that you can say. So for every feature you can rename it, so that will show you how clearly you are modeling it and how you are giving them information more clearly. Okay, that is going to help you in when you refer it in the future also. Okay, and when you complete the model, then make sure that everything is renamed properly. Okay, all the things should be like here also you can see product information, revision, definition. Okay, all these should be filled properly. Okay, and then this should be in defining work. Always part when everything is done, this should be defining work. Everything closed, and if possible, hide this geometrical set so that you can hide all the planes and construction elements here. And always keep this in ISO view. Keep this ISO view, and then save it. Okay, let's save. Okay, so this is how you can. You also can hide this also. Okay, if you want it, if you can hide this also. Axis also you can hide, and then keep it in ISO view, and then save it. When they open the part, so it exactly. Also, you need to fit it, fit the part, and then save it. Okay. When someone opens this, it exactly comes and sits here, so that it is clearly visible for them also. It is very comfortable for them. Okay. Okay, guys. So this was the model done in the last class. Okay. So now let me know your questions. If you have at any stage, if you had any doubts, or if you face any problems during modeling of this part, let me know. Okay. All good, guys? Good to go? Okay. I saved it, and now I'm closing this. So I shared a simple model, this one. So how many of you have practiced it? Any any feedback about this? Guys, I shared a drawing, I believe. Hope you remember on last Friday. I shared a PDF. You guys, anyone tried this? No one tried it since, right? This one or the different PDF? No, no, not this PDF. Not this part. I think different PDF. simple part I shared actually. I'll show you. From this. Yeah, this one. So guys, try to do this. This is really simple part. Okay, a simple bracket. Okay, just for sample. This is 50 is not possible actually. Usually we don't will not have 50 of thickness. This is already shared. Okay, please try to work on this, please. Or you want me to show this? Let me show you how to do this. Okay. So again, I followed the same method. So instead of removing the material, let's directly take this profile. So how to do it directly? Okay, I'll show you. So and this is not usually 50 material thickness is not usually available. So let us consider this around 5 or something, and then we start working on this. Okay. Okay. Let's see this. How you can do this? So say mechanical design, part design. Okay. So this I will insert a body here. Okay. So we can insert a body, a separate body here. So please see, insert a body. So this will be a different, separate entity. It is not will be this. Okay, this will be different. Okay, now let me hide this. Okay, simply how we can do this. So again, go to front view. This is the drawing. Okay, so as this is kind of sheet metal. Okay, please ignore this. This is not possible. Only um, less than 5 or something we have to consider, like 3 to 4 Okay. Okay, so how we can do it quickly? So this is, so this is my front view. So ZX plane I'm considering, and position sketch. Okay, always select position sketch. Here it is, position sketch. Okay, select the plane and then position sketch. Why position sketch? We will have control over the origin and the orientation of the part. So this is my orientation of the part. desired orientation of the part. So this is vertical, this is horizontal axis for me, and this is zy plane I have considered. Okay. Say okay, and now hope you have that drawing with you, or else I'll show you. Okay. What is this? This is kind of, let's consider the outer line. This outer line. Okay. So I'm considering the outer line. Simply, how can you do that? Take this profile. Okay. Can you see this, guys? Profile. Just click on this. Say one, two, three, four, and then say 5 mm. Let's consider 5 mm. Okay. This, and this. Okay. If it is a part, again, as I mentioned, if you follow the manufacturing methodology, then if it is a part which manufactures undergoes machining for the removal of the material to get the shape of that. If it is a block of material, then it's going to undergo the machining process. But if it is a sheet metal, then only bending process or forming process will happen. Okay, to achieve that shape. So this is not a block of material. This is kind of sheet metal. So how we can do that? Simply, this is already done. Okay, now we have to control, we have to take the dimensions now. Let us see. Let me constrain it. Okay, so from here, one horizontal line, and from here one vertical line. So those surfaces or those faces which are important and which should be kept intact should be first. So these are the rules. Okay, and these rules will be changing uh, customer to customer. It will vary from customer to customer. Okay, but most of the people follow this. Okay, if these are the two faces which are getting welded onto some part, then this face is very important. Okay, and this face is also very important, as we assume that these faces will be welded to other parts. Some other block is coming here, for example, kind of block is coming here like this, and this part is going to get welded here. Okay, and we assume that another block is coming here, some kind of part which where this part will be welded. Okay, so that's the reason we consider we are considering it as the important phases, and from the axis I have controlled this phase and this phase. Okay, that is the reason we first control this, and then let us again, this phase should be controlled from here. Okay, this phase can be controlled from here or here also. Okay, I controlled it, and this done. This is constrained. Okay, and this can be constrained. Okay, I consider this as a rough model. If the sheet metal, it's not maybe 3 mm, 2 mm we have to consider. But here, for example, I'm just leaving as it is, like 40. Okay, can have big shape here. Okay, let's consider as of now and see. And now how this should be controlled? This is at an angle. Okay, so you have to click on this and click on this point. Okay, so angle is controlled, say 45 degrees. Okay, now this point has to be controlled. Okay, this point has to be defined. So take for instance. Okay, and this is 40 mm. So let us, I'm offsetting this line. Okay, of 40 mm. I'll offset this 40 mm. Okay, and I'll delete this because we want a line at 40 mm. Okay, so now this is completed. Profile is roughly completed. I'm just showing you, okay, how you can do it. Okay, you can practice it at home. Okay, please practice this and come back to me. Okay, even the dimensions are taken roughly. I showed you only the shape. Okay, only shape I showed you. This is the shape, and this is how we have to consider the dimensions. Okay, let's have a look at this drawing. Okay, and we have three holes: one hole, second hole, third hole. Okay, okay. Okay, this profile is done. If you come out, what is the width of that? It is around 200 mm. Okay, so this is left view, left side view. So in left side view, you can see the width of that. Okay, 200 mm, and the holes are at 100 mm at the center. Okay, 100 mm, nothing but center of this. Three holes are placed at the center. Okay, so how to achieve that? So this is at the center. Now from center, it is 200 mm. That means 100 mm this side and 100 mm this side. So go to pad again, select this profile. Okay, say 100 here, and then say mirrored extent. Okay, what we did, we considered from here and said mirrored extent. Say preview. Now this axis is exactly at the center. Okay, we consider this axis at the center.
Between the doors.
Then we created half of the dimension, we consider 100 mm mirrored extent. Okay, and now create these guys. Hear me? Can you hear me, guys?
Yes, sir. Yes, sir.
Okay, okay. Something happened. It got muted. Okay. So have you seen how this simple model can be done? Simply take this profile and just create this and try to just maintain these dimensions. Okay, in the sketcher and come out and then use the pad option to generate this pad. Okay, and here how you can generate, use only 100 mm. This is the length, the the complete width is 200 mm, but you can, with the help of 100 mm using mirror extent, you can get it. Okay, complete 200 mm. When you use mirror extent, the axis will be at the center. Okay, so we wanted this axis at the center, that's why we use this. And then now, how to generate, how to create a hole here. So what is the, from this face, from this face, this hole is at around 500 mm distance. And what is the meaning of this? Two, 2 times 50 dia hole. Okay, 2 times 50 dia hole here. And if you see here, this is 60 dia hole. Okay, and if I see here, this hole is not dimensioned at all. We don't know the dia of this. That means diameter of this also is given here. Okay, the drawing is saying that this diameter 50 mm dia holes, there are 2 holes in this part. Okay, if this part is not dimensioned, that means dia of this hole is not shown. That means dia, this is 2 times 50, that means 2 holes are available in this part. That means this is 1 hole and this is 1 hole. That's how we need to consider. Okay, this is of different dia, that's the reason the dia is mentioned here, 60 mm dia. This is of the same dia, that's the reason we have not mentioned dia here. Only here only it is shown, saying that only the location, the position of the hole is mentioned. Can you see that? Position of the hole is, from this face it is 167. At 167, you want a hole of dia 50 mm. Okay, this position is defined in the side view. This is front view, and in the side view, if you see where exactly it is located, it is at the center of the part. So you can see this part, this hole is clearly seen here, and this hole is at the center, 100 mm. Okay, the axis is extended here. Now this whole axis is also matching with this hole. That means even this hole is also at the 100 mm. So they both of them are at the center of the part. And you can see, let's switch on the frames. To switch on the frame, we have one option here. Please remember this. To switch on or switch off the views, okay, frame, view frame, you can see here, this is the display view frame as specified for each view. Remember this. If you want to switch on this view frame, then you have to click on this. Again, to switch on, click on this. And also you can see the third hole. Which is the third hole? This one is the first, second. You can see first, this is the first hole. Okay, this is the second hole, and the third hole you can see, because this cannot be seen directly, because this material, this is inside the material. Okay, so that's the reason this is in dotted lines. Okay, here also it is in dotted lines. So actually this is not generated, it should also be generated. Let us try to get the axis of this. Okay, say view, center line is already on, but still it is not generated. Okay, if in drawing, if the center line of the hole is not generated, then what we have to do, we have a toolbar here. This is to generate the axis. If it is circle, direct circle, then you can use this option to generate the axis of that circle. Okay, if there are only 2 lines, then you can use this option, axis line, to generate the axis. Okay, click on this. and click on this. Okay. So now you clearly can understand that all the three holes are in line with each other, and the dimension is 100 mm from this edge. That means they are placed exactly at the center of the hole of the part. Got it? Okay. So now what we want, part roughly created. Now we want to create this holes. Okay. So this is the face. So now I'm going to create without creating the plane. Okay. As I mentioned, we have to use planes to generate the sketch. Okay. But just roughly I'm showing you. Okay. Okay. So directly you can select this face and directly go here and say sketcher, always position sketch. Okay. And look at this orientation, vertical and right side horizontal. Okay. If you change it, then your orientation will change. Okay. This is not the orientation I expected. So if you want to have the same orientation, so you need to select this face, and always you need to keep this vertical is vertical, that's fine. Now this horizontal should be on right side. If it is on right side, then same orientation you can see in the sketcher. Okay. Now there is no change in my orientation. Okay. Now I want to create a simple. So what is the dia of this? It's around 50 mm. Okay. Double click and say 50, and this is 50 mm. And now how to constrain it? Simple. Select the center and select the axis and say coincidence, because part is exactly at the center. So we need to coincide it this with the center. And what is the height of this part? Okay, from where we need to consider that height? Say normal view. And if you check in the drawing, so what is the height of the part from this? From this face, it is around 376 mm. That means this is the bottom face. From this face, height of this part is 376. Am I right? 376 mm. So, guys, you know how to get into this drawing. Okay, we have both here, part and drawing. So, Windows, say drawing, then you will go to drawing. Again, Windows, part. Okay. Now I want a dimension 367 from this. How to get that? Okay. How can I get this? So to get this, you need to project this line. How to project it? We have one option. Okay. That. So you can use this tool. You have this project 3D element. Okay. In drawing, if you want to project it, so click on this and click on this. Okay. Yes. What is the meaning of yellow? It is linked with the 3D element. So we don't want any link with the 3D element. Say mark 1, just right click on this and say mark 1 object and then say isolate. Okay. Again, I'll show you. Right click on this, line 1 object. Okay. And say isolate. It is isolated, so it will not show again the same thing. And then convert this into construction element. Okay. And either you can constrain it here or fix it. Okay. Fixing is not allowed usually, but to save time you can fix it. Okay, now how much is the dimension? So go to dimensions here. So this is the toolbar. Constraints, have you seen constraint? So this, from here to here, I want 367. 367. Say okay. Okay, so this is properly constrained and properly located as per the drawing. Now let me check my sketch is okay. Perfectly okay. It is closed circle, only a single circle. So I'm coming out of this, and now let me finish this operation. Okay, say up to next, and the material will be removed. So circle is done. Okay, what next? We have another. We have one more circle here. Okay, one more hole here. How to get this? So we need to select this face. Okay, the material is removed on this face. Okay, so now dia is 60 mm, and location of this is defined as from this bottom face. This point is 122 mm, and this point is from vertical it is 521 mm. Okay, so that is defined here, this point. And then if you see in the side view, it is again at the center of the part. The hole is at the center of the part. So let us get this part, get this hole done. Okay, okay, now how to get this? So to get this in side view, it is saying that in this view, what is this front view? We have to achieve this. Okay, go here. So this is exactly at the center. We have something here. Create one point here. And this point is from bottom, how much they are showing? From this face, it is 122 with horizontal, and this is 521. Okay, one 22. Okay, and 521 somewhere here. Okay, okay. What have you observed? So I have not projected any line, anything. Okay, so even you can get a point like this, which is not at all allowed. Okay, just to save time I did this, but you cannot directly take dimensions from this solid model. Okay, even it is it will show you, but this is not right method. Okay, so what I am doing, I am just deleting this. Yes, and I'll say, just to save our time, say fix. Okay. Okay, Baba. Let's see. Now I'm going here. So I'm directly selecting this face, and now this is the location of my feature. Okay, which feature I want to now say 60 dia, and now I'm going to project it, and then I'm going to I projected it. Okay, say isolate, and it should be constrained. So instead of constraining, I'm just fixing it. Okay, and convert it to construction element. Okay, and then simply come here and click on select. This is how we have to achieve it. Okay, and this is only for reference we have created. Okay, after creating this, if you want to delete this, it's okay to delete, because we don't need this anymore, because only for reference we created this. Okay, so once you come out, we have already achieved this whole. So if you want to delete this, you can delete, nothing to worry about that. Okay, because all the dimensions will be shown in this. In this I have not shown the dimensions, because just to save the time I fixed it. Guys, hope you understand this. Okay, if you don't understand, let me know, I'll repeat this. Okay, okay, now come out and then remove the material. Okay, up to next, say okay, you are done. Okay, even the second one is done. And what is the third one? Third one is 167 from this face and at the center. Okay, and exactly on this face. So to achieve that, I'm selecting this face. Okay, this one, because we have to remove material here. So I'm breaking rule now. As I said, we always need to select the plane. So I'm not creating in plane, just to save time. Okay, but you know how to create plane and how to do it, right? If you have any question, you can ask me. This is shortcut, we can say. Directly selecting face of the part, and now important is orientation. What is this? It should be vertical, should be on the top, horizontal should be horizontal on the right side. Now, okay, so same orientation. Now this is of 50 dia. This is already one constraint is already created. This is in line with the center. Okay, and now from this side, how much is that? 167 is the center. Okay, that means 167. Done. So okay, let me follow the rule. First I'll project it, then I'll isolate it, then I'll convert it, this construction element, and then I'm going to constrain it. These are the steps to be followed, and then I'm going to give dimension. Okay, define the hole from here as per the drawing. Okay, now come out. Now simple, done. Okay, as per the drawing, we have achieved 3 holes on this part. and this side view. Okay, everything achieved. So this is the part, 3D part. Okay, so this I already shared with you. This drawing already in the form of PDF I shared with you. Try to just achieve this part. Okay, try to work on this part. Do you have any questions in this? Any question, any doubt, any question? No issues at all. You can ask me. Even it is very small. Okay. So you understood how to profile is very simple. This one. With a single profile you can use it. Okay. You can draw this with a using this single profile. See, here you have this profile and this rectangle. If you see rectangle, we have different shapes here. Okay, cylindrical, elongated hole. Okay, cylindrical, keyhole profile. All profiles we have. But because as this is very simple, we can use this. Okay, circular, for circular things we have all these profiles. Okay, we are going to use them all because we are going to, going forward we will start working on a little difficult or uh, models, which you will come to know how to use all these things. Okay, and also we have spline and we have connect curve, or how to use them. Okay, let us see all these things. So for today, any questions, guys?
Sir,
Yeah.
when we open Catia, axis system is not coming, sir.
Yes. So I explained that in the beginning itself. So when you open Catia, access system won't be there.
Yes, sir.
So I'll show you how to do that. Okay. So guys, hope no questions from this model. Okay. Okay. So tools options. Okay. Tools options, infrastructure, then go to part infrastructure. Okay, part document, create an access system. Please make a note of that. So 1-2 times when you do this, you'll remember this. Okay, it's nothing very difficult. You can remember it, but initially make a note of that, or you can remember it. Okay, and how much? What is that? Tools options, infrastructure, part infrastructure. Okay, in part document you can say create an access system. Okay, and how much, what is the size you require? Okay, size of the access system you can define it here. In display you can define the size of the access system. You want to reduce it size, you can reduce it. Okay, you want to increase, you can increase it. Okay, so these are the two things related to access system. Got it?
Yes, sir. I did yesterday, but it not came, sir.
Sorry,
I
you're not
did
getting it?
yesterday. I did same, sir, but access system was not coming, sir.
Are how it is possible here? It should come. This is the thing actually. Is it the same tools, infrastructure,
Yes, sir. Yes, sir.
part infrastructure, part
And
document
in the starting, it is coming like grid, sir. Whole sketch.
coming with grid?
Yes, sir. Grid.
No, yeah, this is access system. Clearly, it is mentioned here. Create an access system, isn't it? You're talking about grid.
Yes, sir. Yes.
See, grid is different option. You can see here. You can switch on or switch off the grid if you want. We have here. I'll show you what the grid. You don't need to get into options and all. Somewhere it is hiding. I'll show you. Remember this, many times I showed you. Okay, if things are not visible, if something is missing or some option is some toolbar is missing, then you can take help of this option. Okay, say toolbars, store or contact, position. Let us see where exactly it is now. Issue with my system here. I'll show you some. We have grid where you can switch on or switch off the grid. For example, even if you go here, you can see here grid. See, this grid you are talking about.
No, sir. In a starting in sketch, there is like some grids, sir. Grid lines like graph.
Here in the part model.
Yes, sir. Yes, sir. Yes.
Yeah, here also you can see the grid, and that option is available here. Then you can switch off it. I'll show you where is the grid. It is somewhere. It is hidden. You have to see that. Grid. But that is different. That is not related with this.
No, sir. Means it is coming, but axis system is not coming like that. Problem.
This is not coming.
Yes, sir. In my system, I did that same thing, sir, in a infrastructure, but axis system it is not showing, sir. That's why I had asked.
That is some strange issue, I think. So, so anyone else is having the same issue? So only you are facing the issue, or anyone else is facing the issue? Maybe while installing the Catia, maybe if you have followed some wrong method, then these options may miss.
Okay, sir.
So we have to see how you installed it. But usually there won't be any problem with that because all these options should be available. So, okay, I'll check and let you know. Okay, why it is not coming.
Okay, sir.
Okay. And any other issues? Any questions in this CATIA related modeling? Like last time we did it, and now we did it. So hope you guys are getting it right. So I know it is difficult because initially it takes some time to see all these new options and new features to remember and to see to remember the location where it is available and names of the features. Okay, uh, keep practicing it. It will be easy for you once you start practicing it. Then just a week, then you will be familiar with the workbenches. Okay, part workbench. What is part workbench? What is assembly workbench? What is drafting? Okay, so how to get into the drafting? You can see assembly design, okay, sketch, and we will be using mostly these things. First, let us complete these things: part design, assembly design, and drafting. Okay, get into this and just click on the options and go through them. Try to understand them. If you have any questions, make a note of them and come back to me. Okay, we will discuss and clear your doubts. And start practicing these models, what we are doing here. Unless you practice, you will not get it. Okay, start practicing, and once you start practicing, you get a lot of error messages where you are missing, what you are missing. Then you will come to know, and we'll correct that, and we'll go ahead. Okay. Okay, guys, if you have any questions, please let me know. If everything clear, then we'll stop it here for today. Okay, and tomorrow, please practice these two parts, and then day after tomorrow, let us discuss if you have any questions on that. Okay, let me know any questions, or else we'll stop it for today.
Sir, tomorrow you are taking class again, right?
Sorry,
Tomorrow again you are taking class?
not tomorrow, day after tomorrow.
Okay, sir.
Yeah, for tomorrow you can practice these models and make a note of the things what you have. Okay, so it's good to have day after day class. Of course, at least you will get 1 day time to practice. Okay, it's also important. And also you are attending classes, right? After completing your classes, then you practice it, and then you come back to me. Okay, then we'll resolve.